Hi everyone, this is your calculations tutorial for Nursing Skills 3. First off, you need to be able to convert between different masses, volumes, and time. So if we're going from micrograms to milligrams to grams to kilograms, you're going to divide by 1,000. You're going from a smaller unit to a larger unit, and the opposite way, from kilograms to grams to milligrams to micrograms, each time you're going to times by 1,000. You're going from a bigger unit to a smaller unit here. From pounds to kilograms, we're dividing by 2.2, and other way we're multiplying by 2.2. From milliliters to liters, you're going to divide by 1,000. The other way, multiply. And for time, minutes to hours, divide by 60 or multiply by 60. So you do need to memorize these conversions. So let's try a conversion. Remember that 1,000 milliliters equals 1 liter. Your question is, your patient said he drank 1/4 of a liter of water. So we'll put that into a fraction, 1/4 of a liter. You must document that intake in milliliters. How many milliliters did he drink? So always turn a fraction into a decimal, 0.25 liters. And if you're going from a smaller unit, milliliters, to a bigger, that way you're going to divide, but since we want to go the opposite way to milliliters, we're going to multiply by 1,000. So that's 3 decimal places over, 1, 2, 3. That's going to be 250 milliliters. From milligrams to grams, or grams to milligrams, the doctor ordered 250 milligrams of a medication. It comes in a 1-gram tablet. What will you administer? So you can go either way. You can change it into grams or change both into milligrams. So we'll try changing both to milligrams. So we have 250 milligrams, and you have 1 gram tabs. So you can do the ratio formula. We have here 250 milligrams. How many tabs is that? And then we have 1 gram per 1 tab. So here you can cross multiply and divide. 250 milligrams times 1 tab equals 1 gram X tabs. And then you can go 250, change your grams to milligrams. We're going to go over here. Divided by 1,000 milligrams equals X tabs, and that will give you 1/4 of a tab. So you're going to take that tab and cut it down into 1/4 to give your dose. Another conversion question. So we're going from micrograms to milligrams and vice versa. The doctor's order calls for 0.5 milligrams. The drug comes in 250 microgram tabs. How much will you give? So the order is for 0.5 milligrams. How many tabs do we need there? And what we have on hand is 250 micrograms per 1 tab. So we need to convert. So let's convert the milligrams to micrograms to whatever we have on hand here. So micrograms are smaller, so we're going to multiply by 1,000. 1, 2, 3. It's going to be 500 micrograms. What is our X there? Equals 250 micrograms per 1 tab. So cross multiply and divide. We're going to go 500 times 1, divide by 250. 500 divided by 250 equals 2 tabs. 2 tabs equals X. So we need to give 2 tabs to get that dose of 0.5 milligrams. All right, so now that we know how to convert, we're going to start with our calculations. These are the ones that are going to be discussed in this tutorial. We're going to do IV fluid administration rates. There's two types of rates. There's the drip rates. So this is the one that is manually done by maneuvering the clamp on the tubing to get your drops per minute. So this is when you don't have an IV pump. Or we have pump rates. So this is the Baxter syringe pump. This is where we're going to input the rate into milliliters per hour. We are going to do completion times via IV therapy medication administration using the 24-hour clock. So you walk into a room, you look at the IV bag, and you calculate what time will this IV bag be over? When do I have to change it again? We're going to do IV drug preparations, so dosages, concentrations, and then weight-based drug calculations, which we often see in the pediatric population. Important terminology. So you need to understand that flow rate means how fast the IV fluid is being administered to the patient. So again, we can manipulate this in two ways. Pump flow rate, so this is via mechanical IV pump such as the Baxter pump. This will be inputted in milliliters per hour. So how many milliliters flow through every hour? Or drip flow rate. This is via the clamp on the IV administration set tubing, and we can alter the drip rate manually. So this is going to be how many drops are released every minute, measured in GTTS per minute, which is drops per minute. So questions are either going to ask for pump flow rate or drip flow rate. So make sure you know which formula you're going to use. Here's our drip rate formula, which you all should be familiar with. It's volume in milliliters over time in minutes times the drop factor, which we see on the administration set tubing pack. And this is going to give us our drops per minute. So then you can calculate and manipulate the tubing to get your drops per minute set. So remember, GTTS equals drops. Drop factor is the number of drops per volume of IV fluid, and this varies depending on the tubing used. For rounding, so with drip rates, we can't count half or a fraction of a drop. So every time you get a drip rate question, make sure that you're rounding to a whole number. So this is the rule of thumb for rounding. If it's less than 5, round down. So 23.333 is 23. And if it's greater than or equal to 5, round up. So 23.6 will be 24 drops per minute. Let's do a drip rate question. The MD has ordered the IV fluid to be administered at 63 mils per hour. So that's your rate that is being ordered. There are no IV pumps on this unit. The drop factor is 15 drops per milliliter. What flow rate will you set? So let's input our formula. So we're going to do volume in milliliters over time in minutes times our drop factor. This is just the formula you've got to memorize. I always like to put the units in. It's like a double check. Equals our drops per minute. GTS per minute. So our volume is 63. We're going to change our hour into minutes, so that's 60 times our drop factor, which is 15. And that's going to give us our drops per minute, so we're going to input that into the calculator. 63 divided by 60 times 15. We're getting 15.75. Since we can't count fractions of drops, that's going to be 16 GTTS per minute. 16 drops per minute for that question. Next question. MD has ordered IV fluid at 83 mils per hour. Your unit doesn't use IV pumps. The drop factor is 20 drops per mil. What flow rate will you set? So set up your formula. So volume in milliliters over time in minutes times drop factor, which is in GTTS per mil, equals drops per minute GTTS per minute. That's what we're looking for. So our volume is 83 mils. Time is, that's 1 hour, which is equal to 60 minutes. Times your drop factor, which is 20 GTTS per mil. Put that into the calculator. Divide by 60 times 20. It's 27.666, which is going to be 28 GTTS per minute. And you can double check your work by crossing out your units. So milliliters over milliliters, you're left with GTTS over minutes. One more drip rate question. Your MD has ordered 250 mils of IV fluid, so we know it's 250 mils to be administered over 2 hours. So change that right away to minutes. 2 hours, so we have 2 hours is how many minutes? We know that 1 hour equals 60, so 2 hours is going to equal 120. We're going to put that in there. Times our drop factor. Here's our drop factor, 10 GTTS per mil. And that's going to give us 250 divided by 120 times 10. 20.8333. That's going to be 21, round up. And let's figure out our units. So mils gets crossed out. We're left with GTTS per minute, which is perfect because that's what we wanted, drops per minute. The flow rate we're going to set is this right here, 21 GTTS per minute. Okay, moving on to pump rates. The formula for pump rate is going to be in milliliters per hour now. First, remember how to convert minutes to hours. So if you have a fraction of an hour, such as 0.5 of an hour or half an hour, that's 30 minutes. 0.33, you're going to just multiply by 60, you're going to get 20 minutes. 0.25, multiply by 60, it's going to be 15 minutes. The other way around, we're going to divide by 60. So 30 minutes, divide by 60, it's going to be half an hour. 15 minutes divided by 60 is 0.25 hours. So either multiply or divide by 60. First question. The doctor has ordered 1 unit of packed red blood cells over 2.5 hours. The 1 unit of blood contains 350 mils of PRBCs, which is packed red blood cells. What rate will you set on the IV pump? So let's remember our pump rate is in milliliters per hour. So volume over time in minutes. So our volume is 350. So we're only doing 1 unit of blood over 2.5 hours. This is going to equal 350 divided by 2.5. 140 milliliters per hour is what we're going to enter into the pump. Next question. So your IV medication arrives in the pharmacy prepared bag labeled below. So here's our IV bag. This is the doctor's order, 500 milligrams IV Q6H of vancomycin. The medication needs to be infused over 2 hours as per the drug monograph. What do you set the IV pump rate to? So let's put our formula down. Pump rate is volume over time. And let's remember that it's in milliliters over hours. So let's look for our volume. We need 500 milligrams of IV vancomycin. So here's our label. So I see here is our volume, 100 mils, 500 milligrams in 100 mils. So our volume is 100. And we have our time. The medication needs to be infused over 2 hours as per the drug monograph. So what are we going to input into the pump? 100 divided by 2 is 50 milliliters per hour. Next question, another pump rate question. The doctor has ordered a bolus, 500 mils over 45 minutes. What's the correct flow rate to set on the IV pump? So this question is asking for pump rate. Same formula, milliliters over hours, which is volume over time. We have our volume, it's 500 mils. Now we have to convert our 45 minutes into hours. So 45 minutes, we're going from a smaller unit to a larger unit. So we're going to divide by 60 minutes per hour. Use your calculator. 45 divided by 60 is 0.75, 0.75. You can cross out your units there. So it's going to be 0.75 hours. And we're going to put that over here. So 500 divided by 0.75, it's going to give us a rate of 666.6667. You can round that to 666.7. So most pumps, especially the Baxter pumps, can let you input up to 4 digits. So for these questions, you can round to 4 digits. So your answer would be 666.7 milliliters per hour. Moving on to IV therapy completion times. So you must know the 24-hour clock. There's no formula. All we're doing here is we're calculating the time. So we'll try a question. A postpartum patient requires 0.5 liters of D5W to infuse at 50 mils per hour. If the IV fluid is hung at 3, what time will the infusion be complete? So it's asking for a time. So let's think, how many milliliters total? So how many mils is infused, administered every hour? So every hour, 50 mils per hour is what is set. How many hours will it take to complete the IV bag? So we have a 0.5 liter IV bag here. So that's 0.5 liters. Since we're going to mils per hour, let's change that to milliliters. 1, 2, 3, it's gonna be 500 milliliters. We started at 3 o'clock. And how many 50 mils is in 500 mils? That's gonna be 10. So that means for this bag to finish, it's gonna take 10 hours. So that's 50 mils times 10 is going to equal to 500. So after 10 hours, 500 mils will have gone through to the patient. So that means we need to add 10 hours to this, 3 o'clock. So you can just count that manually. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1. So that's gonna take us to 1,300. How many hours will it take to complete the IV bag? You can answer that question as 10 hours. And the question is really asking what time will the infusion be complete? It's going to be complete at 1,300. We'll try another one. An IV fluid is infusing at 50 mils per hour with 950 mils of fluid left in the IV bag. So we have 950 mils left. The current time is 12. What time will the IV fluid be finished? So it's asking for completion time. So we have our rate, 50 mils per hour. We don't need to convert anything because we have our units of measurement. So we have 950 mils left. So you're gonna ask yourself, how many 50 mils is in this 950 ml bag? So you can go 950 divided by 50. Equals to 19. So that means it's going to take 19 hours to complete this bag. So we're going to add 19 hours to 12 o'clock. So if we add 12 hours to 12 o'clock, that's going to take us to midnight. And we need another 7 plus 7 hours. So it's going to take us till 7 a.m. So this bag will be complete at 7 a.m. Next question, completion time again. An IV fluid is infusing at 25 mils per hour. Put down our rate. Put down our time. At 18:49, you see 250 mils of fluid left in the bag. What time will the IV bag be completely infused? So we're looking for time. How many of this 25 mils per hour, how many hours to finish that 250 mils? So if we divide 250 mils divided by 25 mils per hour, that's going to give us 10 hours. So 18:49, so 6:49 p.m. plus 10 hours. So if you add 10 hours to this, that'll take us to 4 plus the minutes, 49. So a way to do that in your head, you can say 18:49 plus 12 hours is 06:49. Subtract 2. You can do 04:49. So 4:49 in the morning. Next question. Your medication arrives from pharmacy supplied as a 25 ml bag. If the med infuses at 100 mils per hour, how long will it take the medication to finish infusing? So it's asking for time. Same thing, we can take our volume, 25 mils over 100 mils per hour. So that's going to give us a quarter of an hour, which is equal to 15 minutes. So it will take 15 minutes for the medication of 250 mils to finish at 100 mils per hour rate.